We'll create a new pod named Secure Monolith. The Secure Monolith secures access to the monolith container using Nginx, which will serve as the reverse proxy serving HTTPS. The Nginx container will be deployed in the same pod as the monolith container because they're tightly coupled. Before we can use the Nginx container to serve HTTP traffic, we'll need some TLS certificates. In this tutorial, we'll store a set of self-signed TLS certificates in Kubernetes as secrets. Now we won't dive into all the details here, but we want to be secure, so we'll need some certs. Let's look at the certs we have for this particular application. The cert.pim and the key.pim files will be used to secure traffic on a monolith server, and the ca.pim will be used by HTTP clients as the CA to trust. Since the certs being used by the monolith server were signed by the CA represented by ca.pim, HTTP clients that trust ca.pim will be able to validate the SSL connection to the monolith server. Next, we'll use kubectl to create the TLS certs secret from the TLS certificate stored under the TLS directory. kubectl will create a key for each file in the TLS directory. Under the TLS certs secret bucket, use the kubectl describe command to verify this. The secure monolith pod requires an Nginx config to handle the secure reverse proxy. Let's review the Nginx configuration file that does this. The proxy.conf configuration file causes Nginx to listen on port 443 for secure connections and proxy traffic to localhost on port 80 where the monolith container is listening. This works because the Nginx and monolith containers share a network namespace while running in the same pod. Next, we need to create a config map entry for the proxy.conf Nginx configuration file using the kubectl create config map command. Use the kubectl describe config map command to get more details about the Nginx proxy.conf config map entry. At this point, we're ready to attach the Nginx configuration files and TLS certificates to the secure monolith pod.